One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the podcast. We're still talking about our functional hierarchy, and we're still building our understanding of what that means. Essentially, this is a framework to help us know which problems to tackle first when more than one thing is going on at a time, which is inevitable, or I should say it's an inevitable thing with chronic inflammatory illnesses and complaints. It's never just one thing. It's always a complex intertwining of different metabolic dysfunctions that all tend to promote each other. So just to review very quickly, you don't want to make the mistake of thinking, well, all I need to do is fix my gut, because after all, doesn't health begin in the gut? And the answer is yes, to a certain degree. Or you don't want to fall into the trap of saying, hey, maybe I just need to do a detox and do those things and then just expect everything to fall into place. I would suggest to you, which I've said before, is that if you go on a gut cleanse and you do a detox or do those things individually, and big things happen, you didn't really have a huge problem to begin with. Not to say that those things can't be helpful, but when we have really complicated situations, those things tend to be insufficient, right? The more subjective complaints you have, the more complex your inflammatory state is, the longer you've been that way, and the more things that you or your doctors find in your diagnostics, the more important it is to have a set of guiding principles to make sense of everything, to know where to start. So the first thing that we talked about in this whole functional hierarchy conversation was about the importance of blood flow and how fundamentally critical it is to get blood and the nutrients and everything else in your blood to your cells so that your cells can create energy efficiently. And that requires a couple of things: good blood volume and good blood pressure. You have to have enough iron, hemoglobin, and red blood cells to carry sufficient oxygen to your cells. And it requires having some source of fuel so that your cells can burn that fuel source in the presence of oxygen to make a lot of energy, or what we call ATP, which is going to fuel function and to fuel cellular repair. And in fact, I've taught for many years in the doctor seminars that some of the worst health issues that people come to us with is when someone has a cluster of several problems. Their blood pressure is too low, so they can't push blood and nutrients into their cells efficiently. And they're anemic in some way, because there's different types of anemias. And so they've got low red blood cells, low hemoglobin, or low iron, which limits their ability to deliver oxygen to their cells and to pick up carbon dioxide and get rid of it. And as part of that cluster, they can have blood sugar issues, either reactive hypoglycemia on the low side or insulin resistance on the high side. And two or three of those together amplify each other, so that a combination of those is far worse than either one by itself. And unless you untangle that mess first, pretty much nothing else is going to get better. So it has to be prioritized. So last time I went into some detail on the low blood sugar side of things, and I gave you a few rules for eating to correct or to help control reactive hypoglycemia. Today, and the next episode, we're going to talk about insulin resistance, which is the high side of things. And it's much more complicated from a physiological standpoint than the reactive hypoglycemia, which is why it takes longer to kind of sort through some of the details. But before I get into that, can I ask you to show your support for the podcast by making sure that you subscribe? Most of you are listening on Apple Podcasts and Apple phones, etc. And the more subscribers that we have, as opposed to people who simply listen but never subscribe, moves us up in the rankings so that others can discover the work that we're doing here at the Inflammation Nation. So please take a moment and subscribe, hit that bell, and get notified when new episodes come out. All right, let's talk about insulin resistance and how it is linked to diabetes, particularly type 2 diabetes, which is a completely reversible type of diabetes caused predominantly by how diet and lifestyle and environmental chemicals interact with predisposing genes. Now, basically, insulin resistance, which is its own thing, is the mechanism by which someone develops type 2 diabetes over time. And because type 2 diabetes is simply a more complex version of insulin resistance, we can accurately say that everyone with type 2 diabetes is insulin resistant. That's how they got that way. But not everybody with insulin resistance has or will develop type 2 diabetes, right? So you need to think of these high blood sugar problems as a continuum or a spectrum, which begins with early or uncomplicated insulin resistance, which also can progress to more severe insulin resistance. And if it continues, will eventually progress to become type 2 diabetes, which has its own spectrum. You can have mild type 2 diabetes or really, really severe. So we have these diagnostic criteria to determine if someone is indeed a type 2 diabetic or simply someone who has some degree of insulin resistance who's at risk of developing diabetes. But I also want you to know that there's a transition from insulin resistance to having insulin resistance and being diabetic. And that transition, let's call it transition zone along the spectrum, is what we call metabolic syndrome. Years ago, we also used to call this syndrome X, but metabolic syndrome is the terminology, and now it's actually being called cardiometabolic syndrome or cardiodiabesity, which implies heart disease stuff, diabetes, and obesity as well. But in a nutshell, metabolic syndrome as that middle point or that transition between insulin resistance and being full-blown type 2 diabetic involves not just the insulin resistance, which we'll get to here in a second, but also additional unfavorable changes such as increased blood pressure, which is, to my understanding, the number one risk factor for things like cardiovascular disease. The metabolic syndrome also induces unfavorable changes in your lipid panel, which typically we see that in the form of increased triglycerides and a lower HDL, which theoretically is your favorable type of lipoprotein, so HDL called the good cholesterol, and also tends to promote unfavorable changes in body composition where we have increased belly fat, what is commonly referred to as an increased waist to hip ratio. So if you're measured a circumference around your waist and your hips, if your waist is wider or bigger than your hips, then that's an indicator that you might have metabolic syndrome. And there's also an increased predisposition to creating intra-abdominal fat, or what we call visceral fat, which is fat around your organ systems, as opposed to subcutaneous fat, which again carries less risk. And we've talked about these different types of fats in other podcasts. Now, just like insulin resistance can be early or simple and get worse over time, you can have mild metabolic syndrome, or you can have really severe metabolic syndrome that's a lot closer to the beginning of full-blown diabetes. So again, it's a spectrum, it's a continuum, and it begins or starts with this thing called insulin resistance and then progresses to some degree of metabolic syndrome and eventually becomes full-blown diabetes. Now, this is a really complicated problem, but it's a complicated problem that, dare I say that it actually has some very simple solutions, right? Simple in the sense that there are a few very powerful things that you can do to change your diet and your lifestyle, and a handful of nutritional supplements that can help those changes. But it's hard in the sense that the changes that people need to make to recover or to get rid of this problem are caused by the very diets and lifestyles that they've practiced for years, that they love and that they enjoy. And so the concepts are simple. The solution is fairly simple, but it's difficult in the sense that it's difficult for people to change their diet. It's difficult for them to change their lifestyle. A lot of people will want to either go the pharmaceutical route and maybe take a medication like metformin, or they want to have some supplements that improve their insulin sensitivity, and they want to do that without changing their diet and without changing their lifestyle. Now, what have I said before? You've heard me say it before. You can't out supplement a bad diet and lifestyle. So the supplementation can be very helpful, but in the absence of the proper diet and lifestyle modifications, your ability to conquer the more complicated forms of insulin resistance, metabolic syndrome, and type 2 diabetes, they're just not going to work based on simple supplementation. Now, what do we see in the pharmaceutical world? Metformin is the classic drug that's typically prescribed for people with either insulin resistance, metabolic syndrome, or type 2 diabetes. And maybe we'll talk about that in a separate episode. And, and the reason why that actually might be important is because there's a lot of research being done on metformin, not just in the context of being a metabolic modulator that helps with things like insulin resistance. And by the way, there are natural compounds that pretty much give us the same results. But there's some research now suggesting that, there might be some anti-aging and longevity effects. And to be honest, I'm not quite sure how I feel about all that. You should know, if you've listened to me for a while, I'm not anti-drug. I've taken plenty of them myself, most of it associated with different orthopedic surgeries that I've had. So I'm not afraid of drugs. I'm not afraid of surgery. But if you're looking to use a drug to compensate for the fact that you're not willing to do the harder work of changing diet and lifestyle, then you're going to have some limitations somewhere along the way. And then, of course, you run the risk of negative side effects. Another reason why this conversation is important is because right now there is a huge push, lots of money being spent on advertising for a drug called semaglutide, or you might have heard of it as Ozempic. And it's being promoted as an anti-obesity drug, a weight loss drug. And it's got some really, really significant downsides. And some people, thankfully, on the medical side are speaking out against that and saying, hey, this might not be a good idea. It's one of those drugs that quite literally, if you take it to lose weight and control blood sugar, you have to be on it for the rest of your life. Because if you stop, things get way worse than what you started. And so that should give you pause anyways. All right, so since this entire high blood sugar spectrum problem starts with insulin resistance, I want to spend my time in this episode talking about that because listen, I can easily teach a full day, maybe two, on this topic alone. So in the context of a 20-minute episode, or even 40 if we stack two together, I'm not going to be able to cover everything. So I thought it would be most helpful to talk about insulin resistance, what it is, and then in the next episode, we'll take that conversation a little bit further into some practical strategies. So let's start with a description of insulin and then talk about what it does mean to become insulin resistant. Well, insulin is, it's called a peptide hormone. It's made out of a protein structure, which is different than the hormones that are made out of cholesterol. Those are called steroid hormones. Things like your reproductive hormones and cortisol. So things like thyroid hormones, insulin, they're a different type of hormone because their structure is different. But insulin is this hormone that is released by your pancreas when you eat food. Now, technically, all three of the macronutrients from your food, talking about protein, fat, and carbohydrates, can elicit an insulin response from your pancreas. But practically speaking, the only one we really need to worry about is carbohydrates. And that would be things like fruits and vegetables and sugars and starches and that kind of stuff. Now, to be more precise, if you eat just healthy fat by itself or just animal protein, which is going to have some fat in it, and if you don't eat carbohydrates at the same time, you're really not going to get much of an insulin surge. And depending on the quantity, you might not get any insulin response at all. So for practical reasons, I don't want you to think of fat or protein as causing an insulin response. And this is one of the reasons why things like ketogenic diets, or if you go a little further to the extreme and full-blown carnivore diets, which is only fat and animal products, why these can be very, very advantageous for people with this type of problem, because it gets rid of the thing that drives the insulin and drives the insulin resistance. But if you do eat carbohydrates, especially starchy and sugary ones, which is the larger portion, if you eat those alone or even in combination with proteins, fat, and fiber, but where your carbohydrate intake is too high, then your insulin is going to go up. And depending on how much you eat, it can surge up, and this is going to cause problems. Now, you might be asking whether or not if you do it one time, like you sit down and eat an entire pizza or you eat a gallon of ice cream, right? If a single insulin surge is a problem, that might be a question, or if this is something that has to happen more frequently. And the answer is the latter, right? If you're somebody who does not have a problem with insulin and your blood sugar is under control and you eat a ton of carbs in one sitting and you do that very infrequently, you're probably not going to have any issues unless that becomes part of your habit and part of your routine. So, a single insulin surge will not a diabetic make. But the problem is that carbohydrate-based insulin surging eating habits and sedentary lifestyles are things that most Americans, North Americans in industrialized modern countries, these are things that people practice every single day. So the fact that a single insulin surge won't hurt you is really almost a moot point, since most people are doing it not only every day, but often multiple times a day, pretty much every time they eat, because they're eating carbohydrate dominant meals, or that's their diet. It's just based on carbohydrates, right? So to be clear, the food that is most likely to drive your insulin and blood sugar too high and cause you to develop insulin resistance is carbohydrates. And that means any food with added sugars, eating too much fruit, breads, pasta, cereals, and grains in general, as well as starchy carbohydrates like potatoes, for example. And there's obviously others. While eating things like leafy greens and crunchy, cruciferous or fibrous vegetables, things like celery, broccoli, cauliflower, Brussels sprouts, that kind of stuff, these are also carbohydrates, but they have a lot of fiber and they have a low amount of sugar to be turned into glucose. Now, the fiber might be an issue for other people. We've talked in the past about there are certain fruits and vegetables that if you have this thing called SIBO, or small intestinal bacterial overgrowth, certain fruits and vegetables are just a no-no for you. And some of them are in that list of what we call favorable carbohydrates because they tend to have more fiber and less sugar, and they don't promote as much insulin or the surging of that and blood sugar. So it's a very different thing, for example, to eat a cup of broccoli compared to a slice of wheat bread or a bowl of pasta or a bowl of ice cream. Even though they're all carbohydrates, not all carbohydrates are the same. And so we have to make a distinction between what we might call favorable carbohydrates and unfavorable. And the favorable ones are the ones that have more fiber, less sugar, less carbohydrates, and they tend to produce less problems as it relates to insulin and insulin signaling. Now, let me outline how this works, and I'll save a more detailed and nuanced discussion for the next episode. I want to zoom into the cellular level. Obviously, we're not using graphics, so I'm saying that metaphorically. And I want to remind you that every cell needs energy to function. And for most people, especially those eating standard American diets or similar things, that fuel is going to be carbohydrate or glucose based. And while there are mechanisms to get glucose from the carbs in your diet into your cells that don't involve insulin, exercise is one of them, those mechanisms are muscle and exercise based. So if you're eating a lot of carbohydrates and you don't have enough muscle mass for the height that you are, and you don't use that muscle in the proper ways on a weekly basis that consume more carbohydrates and train your muscles to handle those properly, then you're going to default to insulin as your primary way to control your blood sugar, and that's not necessarily a good thing. So in general, when we eat carbohydrates, we break those carbs down into glucose in our bloodstream, what we call blood sugar. Now that blood sugar needs to be inside your cells for two reasons. Because of your diet and your lifestyle, you need glucose in your cells as your primary fuel source. And that's to contrast it to someone who maybe is burning fat as their primary fuel source. But we also need blood sugar to go into our cells because glucose is actually a potentially toxic molecule, in the sense that the longer it hangs out in your bloodstream, the more potential damage it can do to your cells, which then can promote some very bad things. Things like leaky gut, hormone imbalances, vision loss, numbness and tingling of neuropathy, poor blood vessel and brain health that promotes cardiovascular disease, as well as neurodegeneration and dementia. And in fact, if you want to think of it this way, people with diabetes don't die from diabetes. They die from the complications that come from having too high insulin, too high blood sugar, and being massively inflamed. And along the way, they go blind. They can't feel their toes. They get ulcers that won't heal. Their kidneys start to shut down, and they end up dying of a stroke or a heart attack. I mean, that's not good, quite obviously. Now, the point is that insulin is, in this case, how we control blood sugar. So we can efficiently clear it out from our bloodstream so it doesn't accumulate and cause damage. But here's the deal, without making it too complicated, when you're constantly eating more carbs than you should, and your insulin keeps going higher and higher to handle higher and higher levels of blood sugar from carbohydrates, eventually your cells stop responding to insulin, so you can't clear your blood sugar, you can't get it into your cells, and it hangs out in your bloodstream, causing inflammation and tissue damage, right? So again, the result is high blood sugar, high insulin, cells that are starved for an energy source, which then creates fatigue and cellular dysfunction, and a systemic inflammatory state that actually is coming from several different places, not just from one. And that's not even talking about the links between high insulin and things like thyroid disease and even cancer. Think of it this way, that when someone has chronic low blood sugar, they tend to live longer, but with more chronic illness. But someone who has this insulin resistance that progresses through metabolic syndrome to eventually diabetes, not only do they suffer greatly along the way, they die way too soon. I don't know any way to sugarcoat it. It's serious and it is a big deal. So in one sense, we want to improve blood sugar for the short-term benefits of alleviating symptomatology and improving cellular function and quality of life. But on the other hand, we want to improve this for the long-term considerations, which is decreasing what is called in the research all-cause mortality, meaning that at any given time, if you've got something like insulin resistance, metabolic syndrome, diabetes, you're more likely to die at any given age than your peers of the same age who don't have that problem. Or to say it another way, if you have it and you get rid of it, your chance of living a healthier life for a longer period of time goes up. And that's good for everybody. All right, that's a wrap for this episode. Just a reminder, this podcast is an extension of my private practice where I work one-on-one with people who do have complex and chronic health issues. Now, most of my clients have seen many other doctors without much success, and many, but not all, have some form of autoimmune disease, blood sugar issues, and so on. Hashimoto's hypothyroidism, insulin resistance, metabolic syndrome are the most common ones. But whether you have a simple or a complex case, whether you have those issues or you don't, if your goal is to figure out the root cause of your complaints, and if you're willing to do what it takes to get better, namely proper diagnostics, diet and lifestyle changes, as well as nutritional supplements that are personalized to you, then maybe we should talk. You can find a contact form on my website, which is drnoseworthy.com, or you can use the contact information that's in the episode description. All right, guys, I'll see you on the next episode.